Hello, welcome to East Windsor Lincoln Technical Institute in East Windsor. My name is Mr. Nowak and this is Mr. Morozoff holding the camera, and we're going to go over PV modules today. So what I have is two PV modules, one's back to us and one's front to us, the same type. I want to be able to show you all the same things on both. So on this first one here, you'll notice that we have 72 times 2 or 144 cells. Each one of these rectangles is a different PV cell. So you've got a PV cell here, and there's 144 on here. Trust me, you don't want to count them all. So these first 12 here start at this bar, and the traces send them through and around so that all 72 on the top are connected in series with each other. And all 72 on the bottom are connected in series with each other. And then these bars, these trace bars here, are connecting through this and keeping the parallel connection from this to this, right? So this is one cell, one module, and this is another module, and together they are connected in one large panel. So you've got your cell, you've got your module, you've got your panel, right? Now, we have our superstrate, which is the glass on top. Then we have the actual cell itself, and if you remember from our talk about the cells, the positive type material, the P-type material is on the top, and the negative type material is on the bottom. And what you have is you have a very thin P-type material on the top to allow it to flow through to the bottom, and a very large N-type material on the bottom to get the flow going and to allow more of the electrons to flow through this when it generates power. And they're connected all in series so that you get a higher voltage on this. Now, on the back, you'll see that one side, the positive side terminal, starts here. The other side, the negative side terminal, starts here. So that's going to be connecting to the negative would be this side, the positive would be this side, considering it's flipped over. And then here, this junction is connecting the top and the bottom together so that they are either connected in parallel or series. But we can figure out how if we look here on the back. So we'll look here, and we're going to see the power information. So we can see that we have our maximum power voltage. VMP is 41.7 volts. Now we know that a cell by itself produces about 0.5 volts. And we have 72 cells in series. So 72, half of 72 is about 36 volts, right? So these obviously are producing a little bit more than 0.5. So that means that if we're getting about 41.7, that means that's all of these in series and all of these in parallel with that. So this connection is putting a parallel connection, putting the two positives together and the two negatives together here. And that's giving us more amperage. And what we're getting here for amperage is 10.36 amps, short circuit amperage, which is going to be our highest amperage, just like VOC is about 49.8, which is our highest voltage. So we're experiencing about 50 volts at about 10 amps on these modules, and we're going to collect that. So we can call that about what? 50 times 10, or about 500 watts, right? So these are 500 watt modules. Each one of these will produce about 500 watts in standard test conditions, STC, or 1,000 watts per meter squared. But that is not common. Remember that the 1,000 watts per meter squared of a standard test condition is what you get in a testing condition, meaning a laboratory, what they produce to test these at their highest capacity. What you're most likely to get in the world is about 800 watts per meter squared. So if you come back down here, you will notice that it says dimensions here, standard test conditions, 1,000 watts per meter squared, and then it says AM, 5.25 degrees Celsius, or 1.5, and then 25 degrees Celsius, right? So that standard test is based on this information. You'll have to recalculate this for the more average 800 watts per meter squared, which, as our book said, was PV-USA. That's the standard, photovoltaic for the United States of America. This is basically the information you need. If you wanted to connect to these guys to get their voltage, OC, you would take a voltmeter and you put one here and one here. You'll notice that the positive terminal has a male adapter and the female terminal is the negative terminal, a female adapter. So you could literally plug these two in together like this and short circuit them. So if you wanted to find the VOC, you put a voltmeter here and here, and that would give you the volts in the perfect sunlight. That should give you the VOC, so you can test to make sure that none of the cells are broken. And then if you connect these and put an amp probe on it that tests for DC amps, then you should be able to notice that you have how much, or put the two probe leads into the ends and put it through, and whatever amperage you get here should be close to about 10 amps. If you have 10 amps, let's wait for that noise to stop. Thank you. If you have 10 amps, then the 10 amps show that you have, again, a working current. The current is running through. If you're not getting current or you're not getting proper voltage by testing these two things, then you might have some damage on the module and you should replace it or purchase a new one.